Hello and welcome to this Kistler webinar. My name is Matthew and I will be your IEEE Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window, and anytime during the presentation you can enter a question into the box and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce today's presenters, Lukas, Koch, and Christoph, Klauser. Lukas Koch joined Kistler in 2015. As head of the Road and Traffic business line, he is responsible for the global strategy and positioning of all products according to market-specific needs. Lukas also closely supported the pilot customers and installation of the new KiTraffic Digital system as a project manager. Christoph Klauser is focused on weigh-in-motion technology and is first point of contact to the global sales force for WIM expertise in large and small projects. Within Kistler, he also supports the development team of the new WIM technology and coordinates market launch activities. Welcome both to today's event, and with that, I will pass things along to you to get started.
A very warm welcome to the Kistler webinar about KiTraffic Digital. Christoph Klauser and myself are going to present you today the all-new KiTraffic Digital system and what is behind it. After a short introduction, we are going to show you how the KiTraffic Digital system takes weigh-in-motion to the next level, and we will give you a glance into the specifications. Then we talk about how KiTraffic Digital is going to revolutionize weight enforcement. After that, we explain you the architecture of the system and how you will be able to interface with the KiTraffic Digital system. Then we talk about our first experiences from the road, and last but not least, we are going to explain you the Kistler services that are needed to unleash the full potential. At the end, there's enough time for a question and answer session. Before we get started, we would like to quickly introduce ourselves. My name is Lukas Koch. I am the head of the business field Road and Traffic, and I am globally responsible for the weigh-in-motion business within the Kistler Group. My colleague Christoph Klauser is in his role as the product manager of the business field Road and Traffic, responsible for the development, market introduction and support of the KiTraffic Digital system. Kistler Group is a global company with more than 2,200 employees worldwide and over 60 locations. We are offering dynamic measurement systems and solutions for more than 60 applications in almost all industries. Weight enforcement or traffic data collection are just a few out of the Kistler portfolio. The weigh-in-motion application has quite some history within Kistler. Over 20 years ago, we have started to develop the linear sensor based on piezoelectric technology. Until today, the basic principle hasn't changed, and since the early 1990s, over 50,000 linear sensors have been successfully installed in the road. 2014, we started to develop our own data logger and offering you a full measuring chain. Now with Vim Reloaded, we are very proud to be able to present you a fully digitized system called the KiTraffic Digital. What this is all about will be presented by Christoph Klauser in a few seconds. To get started, we have prepared a short movie.
Every day, an increasing number of trucks roll across highways around the globe. By 2025, the German government expects an increase of 80% in truck traffic compared to 2004. This means a growing risk in road safety, causing thousands of truck accidents every year. and an incorrectly loaded or overloaded truck has a much longer braking distance. In addition, overloaded trucks lead to severe road damage and cause massively higher maintenance costs. An example: the impact of a truck with a total weight of 30 tons equals the damage of 7,500 passenger cars. Weigh-in-motion technology is used for weight enforcement and to collect traffic load statistics. Kistler is the pioneer in quartz WIM technologies, providing innovative weigh-in-motion solutions for more than 20 years. Existing WIM technology comes to its limits with measuring accuracy. In certain situations, a reliable measurement cannot be guaranteed. The all-new KiTraffic Digital system by Kistler brings weigh-in-motion to the next level. It is a completely integrated WIM system that combines proven quartz-based WIM sensors with the latest benefits of digitalization, ready to use. KiTraffic Digital delivers an unprecedented level of accuracy and reliability, driven by the new Linneus digital sensors with a unique design, multiple individually measuring quartz. This allows the sensor to calibrate each quartz, detect tire properties, measure accurately at each driving position. With KiTraffic Digital, Kistler brings to market the most accurate weigh-in-motion system. The new technology accomplishes an accuracy of up to 2% gross vehicle weight. This allows the highest hit rate of enforceable vehicles and thus enables direct weight enforcement. WIM in free-flow traffic is now made easy and reliable, independent of driving maneuvers such as lane changes. The KiTraffic Digital system precisely identifies tire types and condition. It can even detect trucks with underinflated or mismatching tires. The new system calibrates every single quartz element separately to compensate for poor road quality. This makes KiTraffic Digital adaptable to almost all road conditions. KiTraffic Digital demands less installation effort as no loops are required. It uses highest quality electronics and informs the users of the health status of the sensors installed in the road. The intelligent WIM system provides comprehensive data and allows easy integration in higher-level systems, such as weight enforcement or toll collection systems. In short, Kistler has created the most advanced WIM system to date, already installed in public roads. It is the most accurate, reliable, and robust solution, plus it is easy to integrate. Therefore, KiTraffic Digital can clearly contribute to a higher road safety and a more sustainable road infrastructure.
This was a lot of information in short time, so let's go through each point thoroughly and learn how KiTraffic Digital takes WIM really to the next level. So what's really new on KiTraffic Digital? It's important to understand that the core of a WIM system is the sensor, and here we have a brand new sensor called Linneus Digital. It contains still quartz discs like the Linneus sensors you know since many years. But the great new thing about Linneus Digital is that each single quartz disk inside the sensor is digitized and processed separately. And this is the basis for many great things you will learn about in this webinar. For example, it allows to calibrate each single quartz separately and therefore reduces the contribution of the WIM sensor to the overall WIM error, basically to zero. The basic design of the sensor, however, is still based on the 20 years field experience of Kistler engineers. If you take a look at the graph on the right, which shows the sensor signal output, we can see different peaks. These peaks represent the tires of a vehicle which was crossing the WIM site. We can see here a truck which with 4 axles which cross the WIM site. It has single tires on the steering axle and dual tires on the 3 remaining axles. And last but not least, you don't see loop signals here. And that's correct. Loops are not required anymore, as the Linear's digital sensors detect vehicle presence on their own. Vehicle classification, therefore, can be based on axle spacing and tire types and do not require any loops anymore. So let's look at the benefits you get from KiTraffic Digital. And first, let's focus on why Kistler says this is the most accurate WIM system available on the market today. The first reason to see is that each quartz inside the sensor is calibrated individually. This results in very uniform signals over the whole sensor length, and no matter on what position of the sensor you apply a defined force, you'll always get exactly the same signal from the sensor back. And this in the end reduces the error contribution of the WIM sensor to the overall WIM error basically to zero. And in addition, you have seen on the slides before that we get a lot more sensor signals into our higher level KiTraffic Digital system, and these more signals allow highly sophisticated algorithms within the KiTraffic Digital system to compensate specific vehicle effects which contribute to vehicle specific WIM errors, and these effects can be eliminated and reduced to make WIM more accurate. And the last reason why KiTraffic Digital is really most accurate is that we have the capability to reduce the influence of the road on the WIM measurement. With the help of our structural road analysis service, we help to find the best location on the road and define the ideal layout for given conditions. In addition to this, the in-road sensor calibration helps as well to reduce the influence of the road and therefore get most accurate WIM readings. And now let's take a look at the second picture of this slide and the second large benefit from KiTraffic Digital. It is that you get reliable measurements even in free flow open road traffic. Measurements of vehicles which change the lane or which are driving interlane are recorded without any issues. And in case even a wheel touches two adjacent sensors at the same time, WIM measurement is still made reliably. And this is because we have many good signals from the position of the individual quartzes and can process them individually. This helps Kistler to project trajectories of vehicles, and therefore we are not dependent anymore on specific driving maneuvers, but can flexibly process our data to WIM measurements. In addition, we all know that the road has a significant influence on the WIM performance. Differences in road stiffness lead to difference in force signals and therefore in difference in weighing results. Now, Linear's Digital is the first WIM sensor who can adjust its calibration factors of each measuring position, so each quartz position, depending on the road conditions below it. So if you have on the one side of a road a very stiff subgrade, then you have another calibration factor there than on the, let's say, on the middle part where your road is maybe a little bit more soft. And this led to some WIM errors with existing technologies, but now can be easily compensated with the WIM sensor, Linear's Digital. And therefore, this sensor helps to reduce the influence of the road on the WIM accuracy. And last but not least, what you have seen on the graphic on the slide before, we get very nice signals from each wheel, which already indicates the width, the length of the tire patch, and also is it a single or is it a dual tire. And what makes this WIM system even more interesting for enforcement purposes is that we can identify flat tires. This is of course a very crucial point to reduce dangerous trucks on the road and pull them out of the traffic once you detect one of these dangerous trucks. Another unique thing about KiTraffic Digital is that there are no inductive loops required. The vehicles are detected and classified by this WIM sensors itself without any inductive loops. The Linear's digital WIM sensors detect the magnetic fields of a vehicle, and with this information they can reliably classify the vehicles, and therefore in your installation you have less efforts, less material that might get broken, less damage to the road, and less electronics to be maintained in the cabinet. The KiTraffic Digital itself is a very robust WIM system. The Linear's digital sensors in the road have a health monitoring system included, which indicate issues right on time to you, and the whole signal processing inside the cabinet is done by industrial-grade electronics. These industrial-grade electronics are standard products of well-respected manufacturers, and they ensure a trouble-free and reliable equipment of the whole equipment in the road and in the cabinet. So for you this means permanent data acquisition without any interruptions due to reliable sensors and electronics. After you learned how the new WIM system KiTraffic Digital brings a lot of benefits to Way in Motion, let's now take a glance into its specifications. The specification shown here is divided into two sections. First, the Linear's digital sensor, and second, the KiTraffic Digital WIM system. So let's take a look at the Linear's digital sensor. The sensor can carry a load range of up to 124 kilonewton. This represents a wheel load of up to 12.5 tons. And this represents axle loads of up to 25 tons, which can be carried and measured by the sensor. The sensors are available in 3 different lengths. That's what you know from linear sensors already. 1.5 meters, 1.75 meters, and 2 meters. And these sensors can be equipped with cables of 2 separate lengths, either 40 meter or 90 meters. Once the sensors are installed in the road, they withstand a wide operating temperature range. They can be used from -40 to +80 degrees Celsius. And the power to these sensors is supplied via power over Ethernet. So looking at the KiTraffic Digital system, the most important parameter, of course, is WIM accuracy. And as you all know, WIM accuracy depends on many factors. The sensor layouts, the road properties, vehicle types, and you have many different ways of how you can specify accuracy. With the data we have so far, we have good data to show that 2% accuracy is achievable. The EUMO certification to prove accuracy according to a defined standard is in preparation and will be presented to you later on this year. The speed range within which you can use the KiTraffic Digital system is from 3 to 250 kilometers per hour. At the lower end, we have to say that static measurements are not possible with KiTraffic Digital, and at the upper end, there's basically no limits for the signal processing. The maximum vehicle weight the WIM system can carry and measure is also basically unlimited. We are limited by the 25 tons axle loads, which the sensors can carry, but there can be as many axles measured as the vehicle actually has, so no limits on gross weight. And there are no limits on the number of sensors which you can connect to one system. So you can install one system over as many lanes as you want and install basically as many sensors as you want on one lane. The system also supports ANPR cameras and comes with a CE conformity certificate. Its communication interface is Ethernet, and these interfaces are presented to you soon in one of the next slides in more detail. Efficient enforcement of overloaded vehicles is a problem in many countries. So let's see how KiTraffic Digital can support here. Today, weight enforcement is mainly made with a pre-selection approach. This means in most countries there is a WIM system installed somewhere on the highway, and a little bit further down on the road there is a static scale, maybe next to it on a parking lot, where the static weight is measured and used then for legal processing in case there's an overload detected. With this approach, of course, you have quite good efficiency on your static scale, as no correctly loaded vehicles are normally stopped and checked. And the good thing about this as well, that you can pull dangerous trucks immediately out of service. However, you're very limited in the number of trucks you can check and measure on the static scale. And the large majority of trucks is just driving by, and you don't get legally usable data for weight enforcement for these trucks. Few other countries already implemented a direct enforcement weigh-in-motion approach for weight enforcement. There, the national legislation is already in place, and a certification on how to approve WIM systems to provide legally relevant data is also established. And with this approach of direct weight enforcement, all passing vehicles are controlled, and each vehicle which is detected as an overload can be processed in front of court. So now you have a 24/7 weight enforcement with the same number of staff in place. So how can KiTraffic Digital support direct weight enforcement? Its main contribution is to provide data which is valid for legal purpose. As we learned, the weighing error with its new WIM system is reduced to a minimum. In addition, invalid measurements are reduced, as many driving maneuvers can be detected. If a driving maneuver actually causes an invalid measurement, it can be easily flagged and discarded from the enforcement process. And thanks to its health monitoring feature, KiTraffic Digital can indicate when sensor failures lead to wrong measurements. However, the legal part of direct weight enforcement still needs to be provided by local governments. Here, Kistler can only support with his expertise, but the work needs to be done at the local countries. To sum it up, KiTraffic Digital enables a highest rate of enforceable vehicles and therefore paves the way to direct weight enforcement and maximum road safety and a sustainably managed road infrastructure. Weigh-in-motion systems are often part of more complex systems. So for system integrators and end users, it's important to know how they can integrate this weigh-in-motion system into their existing infrastructure or new projects. That's what we're going to address in the next chapter. Before we go into details about the interfaces, I want you to understand the architecture of the WIM system. The Kistler scope of the KiTraffic Digital system is shown with a blue frame here. It includes the sensors which are installed on the road, and as you learned, there can be an unlimited number of sensors and lanes connected to the KiTraffic Digital system. And in addition, third-party devices like optional LPR cameras can be included. In the cabinet, there are the electronics, which consists of an industrial PC, a power over Ethernet switch, and a router. And of course, the software and the configurations running on these devices. The electronics in the back panel are selected and configured for highest WIM performance by our engineers. They come pre-wired and pre-configured from Kistler for easy installation on site without any errors and troubles. Higher level systems, like for instance electronic toll collection systems or back offices of a direct enforcement system or traffic data centers, can easily interface with KiTraffic Digital. On the one hand side, a graphical user interface is available to provide easy access to data and to the settings and make changes in settings and configurations and the commissioning by humans. The pull communication via the REST API and push via an Ethernet stream enables flexible integration into these higher level systems and to exchange the data from KiTraffic Digital to these systems. First, let's look on the graphical user interface. Here we can see the general screen with the data in the center, where we see for each vehicle which is passing the WIM site, the timestamp, the lane where it was driving, its gross weight, etc. All the data which is acquired by the WIM system. We see a general status on top, for example, that the system is currently measuring, and on the left side we see the menu which guides you through an easy process during the commissioning or the calibration, for example. With this graphical user interface, you have easy access to all available data records and can access this user interface via standard web browsers like Firefox or Google Chrome. So there's no software that needs to be installed on your PC locally. On the graphical user interface, you also have access to each single vehicle data record which is stored on the system. Let's take a look here at just one example. We have here a truck. We see the overview image on the right, which was captured by the WIM system. In the center of this graphical user interface, we first have some general information, for example, the timestamp or the lane where the vehicle was driving, or the meteorological ID, which helps to ensure that the data acquired is still in line with the certified configuration of the system. Then there is some general information on the vehicle, for example, the license plate, the class, or the vehicle length, and some data on the weight, of course, the gross weight, the imbalance, left-right distribution of the weight. Furthermore, there is some information on the movement shown, the vehicle speed, the driving direction, and there are more details on each single axle provided. This example here, we have a truck with 6 axles, and so you get on each axle the actual weight and the left and right wheel distribution and the type of each wheel, so if it's a single or it's a dual tire on the left side and on the right side. And of course you get the spacing between the different axles. And last but not least, the system provides here information if warnings or errors were detected, so if any irregularity was observed during the measurement. This could help you to, for example, discard a measurement from a direct weight enforcement process. Let's take a brief look at the menu on the left side of the user interface as a last step. Beside the measurement information, you have simple menus to go through the site setup, to go through the calibration and set the device in a way that it's well corresponding to, for example, any kind of higher level system. So the whole user interface is designed in a way that is easy to use and easy to set up for users which are not very much experienced with it. In many cases, WIM systems are integrated into higher level systems. For these systems, it's important that there is a machine-readable interface of the data which is provided by the WIM system. KiTraffic Digital offers both a pull and a push communication. Pull communication means that the higher level system can pull the data from the WIM system every time that it wants the information. Maybe every 5 minutes, or just once a day, or only once a month. KiTraffic Digital offers a secured REST API. There you can access, filter, and download the data in flexible intervals with some standard commands. Kistler provides a quick and easy to understand documentation of this REST API interface based on Swagger, where each command is described precisely and can be even tested out on devices. The data provided for each single vehicle is a JSON formatted data string. Looking to push communication, this means the WIM system pushes data immediately after its availability via webhooks to a higher level system is possible too. In this way, it can be sure that the data is immediately received by the host system and that it can be immediately processed and, for example, displayed on a variable message sign, or other immediate actions can be immediately taken. So no need to wait for the data or for a certain pulling interval. The data string per vehicle is exactly the same. It's JSON formatted and shown below here on this picture. So what we see here is, for example, the gross vehicle weight, the vehicle on the left, on the right side, so the imbalance. We see the velocity. So basically all the data we learned from the graphical UI is also available in JSON format in push and pull communication and can be digested by any kind of a higher level system for any kind of purpose you need. We now learned quite a lot about KiTraffic Digital, and I think it really looks great on paper. But we now need to see a proof on how it performs on the road. That's what we're gonna look at the next couple of slides. First of all, I would like to introduce the highway installation on a Swiss highway to you on this slide. We see a couple of pictures from the installation process, starting at the top left side with the preparation of the sensors before they are installed, going then to the top right where we see the sensors finally prepared for grouting in the slot next to it. On the bottom left we see the optional in-road calibration procedure at this side, and then finally the picture on bottom right side with the final layout of 4 rows of sensors at this test site in Switzerland. After installation and a certain period of successful operation under real traffic conditions, we conducted a first measurement campaign at this site. Again, a few pictures giving an impression on what happened there. On top left, again, the sensor layout and the site where the measurements were conducted. We used on top right to see a 4-axle truck. This is shown here at the moment of the static weighing for reference weight capturing. And on the bottom left side, a 2-axle truck, which was used here in preparation with one of my colleagues. And on bottom right side, the 5-axle trucks, which we used for the test runs. I'm sure you're now very curious to see how the WIM system performs under these conditions. The measurement campaign at this site was set up in a way to show you a great variation of speeds and vehicle types within a given time frame of these campaigns. In this time frame we were able to totally make 49 runs, and we had 5 trucks used in this measurement campaign. The runs were mainly made at 80 kilometers per hour, but we had one truck, the 2-axle truck loaded, which made runs at all 3 speed levels, 30, 50 and 80 kilometers per hour. So taking a look at the graphics here. The graphics on the left shows the data from the 2-axle loaded truck at 30 kilometers per hour, and we see at the red point the average value of the gross weight of all 7 runs, and in blue the standard deviation of all 7 runs is indicated. So we see here very nice that the average is very close to 0 and the standard deviation is about plus minus 1% at 30 kilometers per hour. Looking at the same truck at 50 or 48 kilometers per hour, we see again that the average value is very close to 0, but the standard deviation is increasing. It's going up to nearly 2.5% gross vehicle weight error. Taking a look at the same truck again then at 80 kilometers per hour, it's the first graph here. We see again the average value of gross weight is very close to 0 and the standard deviation is below 2% accuracy. The same truck empty is the next graph, and this shows even better standard deviation around 1.5%. Then we have 3 other different trucks which made each one 7 runs. Also for these additional trucks we see very good average values, very close to 0%, and this is a great proof that our compensation algorithm for vehicle types works perfectly well, and we get there standard deviations between 1 and 2%, whereas the very last truck really observed great performance significantly below 1% gross vehicle weight. And so we see all standard deviations are below 2.5%. Looking at only one speed level, we get even below 2% standard deviation. So we think this is really a great starting point for our OIML certification, which we will present to you later on this year once the measurements are finally conducted.
In order to unleash the full potential of the KiTraffic Digital system and bring your VIM installation onto the next level, Kistler is offering you various services. Before the installation, it is crucial to understand the road condition. Therefore, Kistler is offering a structural road analysis where our road engineers and experts are conducting measurements in order to characterize the road properties and simulate and analyze the data. Based on the simulation and the analysis, we are able to recommend you the best location and best layout to install the sensors. During the installation, it is very important that the system and the sensors are installed in an appropriate way. That's why Kistler is requesting that all the installation personnel is going through a training and certification procedure of Kistler. During the commissioning, we are able to assist you remote or on-site, or help you during the initial calibration and verification in order to make the commissioning successful and quick. During the operation, you might want us to give you an extended guarantee on the sensors, which we are offering up to 5 years, or we can even support you or execute a periodical maintenance service for you, meaning inspection, calibration and maintenance of the system in order to keep up the best possible performance. With the KiTraffic Digital, we are aiming for maximum accuracy that was never achieved before and ensure highest possible lifetime. In order to do that, it is highly recommended that you order a structural road analysis before the installation of the system. It gives you clarity about your asphalt or concrete pavement conditions and whether you are even able to meet the requirements of the end user. It will reduce your financial risks if you cannot hand over the site to the end user because of low performance or bad accuracy, and it will also reduce technical risks, meaning early failures of the equipment in the road. We are trying to make your life as easy as possible. You tell us where, and we organize the rest for you. We perform a profound assessment of site and road geometry. We organize a road surface characterization and structural road quality measurements. Our service engineers will run a multi-parameter FEM simulation, and at the end you will get a Kistler report with our recommendation for the best layout and the best location to install the system. As mentioned before, we are requiring that each installation is supervised by a certified service engineer. Kistler is offering a training in order to certify your personnel on the full installation procedure of the KiTraffic Digital system. This person will learn and gain know-how from our experienced service engineers, and it will enable him to install sensors and system without the presence of Kistler staff. In order to grant you the standard warranty of 1 year or an additional warranty extension of up to 5 years, it is mandatory to document the installation through the Kistler VIM service app. Once you have uploaded the data, a Kistler service engineer will have a look at it and approve the installation. You will be able to export a PDF report of your installation, track the warranty status of the site, or have a look at an overview of all the installed sites. Last but not least, you will be informed about latest technical developments through the app. Please follow the QR code or go to our Kistler website in order to download the service app. With that, we already have reached the end of our KiTraffic Digital webinar. I would like to thank you for attending, and I hope you have enjoyed our presentation. Now it's time for questions.
Thanks so much, guys, for that great presentation. And thanks to all the audience members for sticking with us. We're now moving into the live Q&A session. If you haven't already submitted your question, you may do so now by entering it in the Q&A box and clicking submit. We'll try to get to the question before the close of the webinar. Okay, now our first question from the audience. What are the sensor lengths available?
I think there's a quick question we can answer. So we've got 1.5 meters, 1.75 meters, and 2 meters sensor length available.
Excellent, thank you for that. Okay, next question from the audience. Starts with a compliment. Excellent products, congratulations. What was the sensor spacing at the test site?
So the sensor spacing at the test site was very specific to that site. We have derived it based on a structural road analysis and the expected traffic type and traffic velocity we expect there. The spacing is not linear, so there's a different spacing between first and the second row, second to third, and the third and the fourth row. So this will be something that is then specifically defined for your site, given the information you are providing us for the site.
Excellent, thank you for that. Okay, next question from the audience. You mentioned left and right axle weights. Can you provide the per tire weight?
So I'm not sure if I understand this question 100% correctly. We give you one weight on the left side of an axle. We assume that this is at least a wheel weight. So you get exactly these wheel weights, or every wheel which is crossing the sensors, you get the weight from. So I would answer this question with yes. So you get one weight per wheel from the rim system.
Great, thank you. Okay, next question from the audience. Can the user interface be translated to Hebrew?
Yes, of course, this is no problem. The architecture or the infrastructure of our software is accordingly that we can translate it to any language. We just need to have the words translated. This is done very, very fast.
Wonderful, thank you for that. And I just want to remind the audience, you can submit your question by entering it in the Q&A box and clicking submit, and we'll try to answer it before the close of the session. Okay, next question from the audience. Can a vehicle classification scheme be loaded into the logger for FH?
I think there's quite a lot of questions received about vehicle classification. And with the KiTraffic Digital, vehicle classification is actually absolutely no problem. We have the information from the force sensors on each axle, so we know axle spacings, we know number of axles. As you've learned, we know even tire types. So vehicle classification based on this information is absolutely no problem. You also learned that we have magnetic field sensors included, so we get magnetic signals, so we know the vehicle dimensions also with the overhangs, and all this information can be taken into account for vehicle classification. And you of course need to know that every country around the world has its own classification scheme, at least nearly, and the implementation of various schemes is possible in our system. So at the end we just need to know the definition of a certain classification scheme, so which class has what kind of axle spacings and characteristics defined. I think this question here referred to the FHWA classification scheme, and this will be definitely one which will be implemented from the beginning. And if other classification, more specific classification schemes are required, it's no problem to implement.
That's great. Thank you for that. Okay, next question from the audience. Would it be possible to get raw signals from every quartz into our system?
So the raw signals from the sensors are processed into the industrial PC in the cabinet, where a little software from Kistler is running that is interpreting and these raw signals and doing all the calculations. Your operating system will be interfacing with that software, where you get all the processed and calculated data.
Excellent, thank you. Okay, next question from the audience. How about pavement evenness?
Yeah, thanks for that question. That is really an important topic, talking about enforcement. So in order to achieve and highest accuracy, it's certainly very helpful to have a very good road. There's a white paper from Kistler that describes the minimal requirements towards a road in order that you certainly achieve satisfying results. Further, it's also important to understand how your road actually is, to understand the properties and to characterize it. With all that information and the ability to calibrate each single quartz separately in the linear sensor, we are able to adjust also to some non-optimal road properties and characteristics and compensate some of those effects.
Great, thanks for that. Okay, next question from the audience. Could you provide more info about the lack of loops, and what is the presence detection field height and width?
Yeah, that's certainly one of, we would say, the big innovations on the digital sensor, that we don't need any loops anymore. We have some magnetic field detectors inside the sensors, so those loops are not needed. We really can detect the presence of the vehicle, of the truck, and we can also detect the width of the truck, so we have basically a full footprint of the vehicle.
Great, thanks for that. I'd just like to remind the audience you can submit your question by entering it in the Q&A box and clicking submit. And our next question is, how are the sensors calibrated on site?
This is another important question, and great that you ask this. So calibration of WIM sites, it's of course always a topic. And the KiTraffic Digital here just uses the methods that you all know. So basically you rent a truck, you do the static weighing of the truck, and then you do a couple of runs over the WIM site, and therefore get the calibration values calculated by a WIM system, and therefore then compensate some of these effects. The KiTraffic Digital is calibrated in the same way, so you also do the truck runs with known weights. And here then at the end it comes to the point on how far we want to further optimize the WIM system. As you've seen on the graphics about our measurement campaign, and where we had all the average weights very close optimized to 0%, this requires then some specific calibrations, for example for specific vehicle types, or if we see some behavior at a particular site where the road maybe was not perfectly ideal and is behaving a little bit different depending on the driving position. Also truck runs with different driving positions can be done to calibrate the system. So we have here also, based on the calibration and the efforts we put in, we have certain parameters to play with to further optimize the performance of the WIM system. But yeah, to sum it up again, the basic principle behind the calibration is still the same. So what you know, the truck run.
Excellent, thank you for that. Okay, moving along to our next question from the audience. What is the life expectancy for this new sensor? Is there any performance difference if installed AC versus PCC?
I especially want to address the life expectancy of this sensor, and it's good to make this a topic here in this Q&A session again. We want to let you know that we have installed the first generation of these sensors already 3 years ago. So the first sensors survived 3 summers and 3 winters in saying Swiss conditions, so quite cold temperatures in winter as well. And these sensors very well survived and are working today. But of course, we are not only relying on a couple of prototypes which were installed at a certain period in time, but we also added extensive laboratory testing at different loads, at different temperatures, exposed to different chemicals and so on. And taking all this into account, we see well, no degradation of sensor performance over time. And in addition, what you need to understand about the quartz-based WIM technology, and that's true for all quartz WIM sensors from Kistler, they don't show any degradation over any kind of load cycle. So these sensors are extremely stiff, and the quartz disc, they have absolutely no fatigue inside the sensor. So from this point of view, the sensors would last forever. If we now take a look, of course, at an installed sensor in the road, normally the sensors are replaced after between 5 to 10 years if you do some maintenance on the road and make sure that the sensors are, for example, well flush grinded with the road. They really get these long lifetimes, and here we expect the same lifetimes for the Lineas digital sensors, these new ones, like we have for the existing Lineas sensors, which you know since more than 20 years. So from our point of view, there's mainly the road, the limiting factor in the lifetime of a WIM sensor from.
Thank you for that.
This,
that was
sorry,
great.
yeah.
Oh.
So sorry, there was just a second part of this question about the type of the pavements, and I think as the road is a limiting factor here, it's also giving then here the type of the pavement is somehow the limiting factor of the lifetime of the sensor in the road. Sorry, Matt. Yeah, now you can go on.
Excellent. Thank you for that. Okay, and we're going to continue answering questions from the audience. We will continue until the top of the hour. Okay, next question. When will the product be available?
So the year 2020, we have to focus on doing pilots together with customers. We already have couples to follow until the end of this year. And then we are ready for more pilots together with you, or even bigger project starting into 2021. We are certainly happy to discuss with you your project or tender face-to-face, hopefully in the upcoming InterTraffic next year. If there is a tender to prepare for next year, we are even happy to support you already this year to prepare the solution or your project.
Excellent. Thank you for that. Okay, next question from the audience. How do you integrate ANPR? It's actually 3 questions. I'll say them all, but I can go back to them each. How do you integrate ANPR? Which ANPR manufacturers are already managed? And how could I integrate existing ANPR cameras?
Christoph, do you
want to
take that on?
Are you going to take this question? Yeah, thanks. So ANPR, it's automatic number plate recognition cameras. So basically, we have a platform with open interfaces on our WIM system where we can interface with other, let's say, third-party devices. It can be a camera, but it can also be kind of other sensors. At the moment, we're working with one supplier. It's Siemens, but generally spoken, all ANPR cameras which have an open interface and provide their data on a machine-readable interface normally can be integrated into our system with some small efforts. So at the end, it will be a decision. If you have a project with a specific camera, please approach us, and we'll discuss the best way on how to do the integration and the merging of the camera data and the WIM data. So the WIM system here is quite flexible.
Excellent, thank you for that. Next question from the audience. I'm wondering about dual tire detection. Is it possible to detect dual tire without 45-degree piezo sensors on the road?
Here again, I would like to recall you one of the first slides we had in the webinar, where we saw the raw data output of the WIM sensors. There we easily saw the peaks and the shapes of tires which were passing the WIM sensor, and we had these properties of a tire directly from the one linear digital sensor. So there was no tilted piezo or other sensor installed at this site. Really, when we did this raw data, we captured this graph of the raw data. It's really on the linear digital sensor, and there you get the information like single dual tire, the width of the tire, the lateral driving position, if the tire is flat or if it's well inflated. So all this information is gathered with this one linear digital sensor, and there's no additional sensors like piezo sensors in 45-degree needed to get this information. I think this is also something new, and some of the innovations which is coming with this sensor, which needs to be well understood, and which is great that we can point it out again.
Great, thanks for that. And it looks like we have time for one more question. Question from the audience. Is it possible to install Kistler Linneas with low temperatures?
I think this question, or Lukas, you want to go on?
I can start and you can conclude if that's okay.
Of course.
Yeah, it's no problem to install linear sensors at lower temperatures. The limiting factor here isn't the sensor, it's really the grout, and we use the very same grout for the linear digital sensor as we do for all linear sensors. Anything to add, Christoph? Or
no, that's fine. Yeah, the temperature is not depending on the sensor, but on the grout. That's what you said, and that's the limiting factor for us with the installations. And I think we all agree it's very important that the sensor adheres well to the ground and then the grout to the pavement to not have any safety risk on the road. I think that would be really the worst case. So that's the big reason why we need to stick to these rules and make sure that there's no humidity and high enough temperature during the installation available.
Excellent. Thank you, guys. And that does bring us to the end, so we are going to wrap things up here. I'd like to thank you again for that wonderful presentation and taking the time to answer the questions from the audience. I'd like to also thank the audience for staying with us and submitting those great questions. You will be receiving an email from us following the conclusion of this event with a link to the on-demand version so you can come back and rewatch. In addition, you can download a copy of a PDF copy of the slides. Thank you very much for being with us here today. Take care and have a great day.